networks function and their significance in today's digital world? Well, let's unravel this mystery together. An overlay network is a virtual or logical network that is created on top of an existing physical network. Think of it as a network within a network, sort of like a matryoshka doll, where smaller dolls nest within the larger ones. This ingenious creation serves several purposes. For starters, it provides a more flexible approach to networking. What does that mean? Well, it essentially removes the hard-coded constraints of a physical network. This means that the configuration can be adjusted according to usage or function and not be restricted by the physical limitations of the network. But that's not all. Overlay networks also offer better access management. They achieve this by logically segmenting and joining devices. This is a game changer, as it eliminates the need to manage these components physically, which can often be a tedious and time-consuming process. In addition to flexibility and management, overlay networks also enhance security. They do this by segmenting traffic and restricting access by groups, individuals, or devices. This is particularly beneficial in today's world where the threat of cyber attacks is ever present. Lastly, overlay networks improve redundancy and efficiency. How so? Well, with an overlay network, traffic can effortlessly change routes based on network conditions. This leads to improved redundancy, as there are multiple routes the traffic can take, and enhanced efficiency, as the best route can be chosen based on the current network conditions. So in a nutshell, an overlay network is a virtual network that sits on top of a physical network, providing a more flexible, manageable, secure, and efficient solution. It's like having the best of both worlds, the reliability of a physical network and the flexibility of a virtual one. Now that you know what an overlay network is and its purpose, let's dive deeper into its key components. What makes an overlay network function as it does, you might wonder? Well, it's all about the key components that work together to create this powerful networking tool. At the core of an overlay network is the virtual or logical network. Think of this as a network within a network. This virtual network is created on top of an existing physical network. It's not a physical entity that you can touch or see, but rather a logical construct that exists within the software. This layer of virtualization allows for a high degree of flexibility and customization. Now let's talk about traffic direction. In traditional networks, traffic follows a predetermined path based on physical links. However, overlay networks allow traffic to be programmatically directed through new virtual routes. This means that the path of the data can be controlled and manipulated in a much more flexible manner. It's like having a GPS that can dynamically reroute your data based on real-time conditions. And what about compatibility? Overlay networks are designed to support various network protocols and standards. This includes VXLAN, BGP VPNs, and IP over IP technology such as GRE or IPsec tunnels. This means that overlay networks can seamlessly integrate with a wide range of existing networking technologies. In other words, they're built to play well with others. So, to sum up, the key components of an overlay network include a virtual network built on top of a physical one, programmatically directed traffic, and support for a wide range of network protocols and standards. These components work together to create a network that is flexible, adaptable, and compatible with existing technologies. They allow for efficient and secure data transmission, while also providing the ability to easily manage and control the flow of data. And there you have it. These components make overlay networks versatile and highly functional. They form the backbone of this powerful tool, enabling it to revolutionize the way we think about and manage networks. So the next time you're navigating the digital world, remember the vital role these key components play in making it all possible. So what are the benefits of using an overlay network? Imagine a system that's not bound by the physical limitations of your hardware. One that provides you with the ability to adapt and configure your network based on your unique requirements. That's the magic of overlay networks. Their primary advantage is flexibility. They break away from the hard-coded constraints of a physical network, enabling you to customize your network configuration based on usage or function, but that's not all. Overlay networks also offer significant benefits when it comes to management. By segmenting and joining devices logically, these networks remove the need for managing these components physically. Think about it like this. It's the difference between moving pieces around on a physical chessboard versus doing it on a digital one. The latter offers you the ability to move pieces around with just a few clicks. In addition to flexibility and management, overlay networks also enhance security. By segmenting traffic and restricting access by groups, individuals, or devices, they create a protective layer that shields your network and data from potential threats. It's like having an invisible shield that safeguards your digital assets. And let's not forget about redundancy and efficiency. With an overlay network, your traffic can easily change routes based on network conditions. This ability to adapt and reroute can significantly improve redundancy and efficiency, ensuring your network always performs optimally. It's like having a network that can instantly find the fastest route in a traffic jam. In a nutshell, overlay networks offer a more flexible, manageable, and secure networking approach. They can adapt to changing conditions, protect your data, and optimize performance. They're like the superheroes of networking, providing capabilities far beyond those of traditional physical networks. With these advantages, overlay networks prove to be a valuable tool in our digital world. How are overlay networks deployed, and where does virtualization occur? Let's dive into that. Overlay networks are not an all-or-nothing proposition. They can be incrementally deployed on end-user sites or hosts that are running the overlay protocol software. This means you don't have to flip a switch and convert your entire network at once. Instead, you can gradually introduce the overlay network into your existing system. This is possible without the cooperation from internet service providers, making it a practical and adaptable solution. Now, where does the magic happen? Where is this network virtualization performed? It's at the network edge. The edge of the network is where the network's resources and services meet the end user. Here, the overlay network is created, while the remainder of the Layer 2 or Layer 3 network remains unchanged and doesn't need any modification. This means that you can implement advanced networking features and strategies without having to overhaul your existing hardware or infrastructure. But why is the network edge so significant? Well, the network edge is the frontier of performance, security, and innovation. It is where the user interacts with the network, where the data is generated and consumed. By enabling virtualization at the network edge, overlay networks can provide improved performance, better security, and greater flexibility. Moreover, by virtualizing at the network edge, overlay networks can keep up with the increasing demand for low-latency, high-bandwidth applications. This is crucial in today's world, where real-time services and applications are becoming the norm. In essence, the deployment and virtualization process of overlay networks is a testament to their adaptability. With incremental deployment, overlay networks can be introduced gradually into an existing system without causing disruption. And by virtualizing at the network edge, they can provide improved performance and security and keep up with the demands of modern applications and services. This deployment method and virtualization location make overlay networks adaptable and efficient. How do overlay networks function in real-world scenarios? Let's dive into a few examples to illustrate their practical applications. The first example that comes to mind is content distribution networks, or CDNs. These are essentially overlay networks that integrate both forward and reverse caching functionalities, typically managed by a single entity. Here's how it works. Customer data is replicated on CDN servers. Whenever a customer updates their data, the CDN network subsequently refreshes the contents on its cache servers. This way, CDNs ensure that users get access to the most updated data in a swift and efficient manner. Another real-world application of overlay networks is found in peer-to-peer file sharing services. If you've ever used services like Napster, Nutella, or DC++, then you've already had a taste of overlay networks in action. These platforms use overlay networks to distribute files across multiple peers, rather than relying on a centralized server. This decentralization not only allows for greater scalability, but also ensures that the system remains resilient, even if individual nodes fail. Now, you might be wondering, how does this all tie back to the advantages of overlay networks we discussed earlier? Well, in both these examples, Overlay networks provide a flexible and efficient solution. They enable better data management, enhance security by segmenting traffic, and even improve redundancy by allowing traffic to change routes based on network conditions. But that's not all. By allowing traffic to be programmatically directed through new virtual network routes, overlay networks remove the need for physical links. This means that they can be deployed incrementally on end-user sites or hosts running the overlay protocol software, without any need for cooperation from internet service providers. So, whether it's delivering content swiftly via a CDN or enabling a more resilient file-sharing system, overlay networks are making waves in the digital world. These examples illustrate the practical applications of overlay networks. What challenges do overlay networks face, and what does the future hold for them? Overlay networks, like many technological advancements, are not without their hurdles. A primary challenge lies in their complexity. Unlike traditional networks, managing and troubleshooting an overlay network requires a more in-depth understanding of both the physical and virtual layers of the network. This complexity can lead to issues in diagnosing and resolving network problems. Another challenge comes in the form of bandwidth overheads. Overlay networks, by their very nature, introduce additional layers to the networking stack. These layers, while providing flexibility and security, also add to the data that needs to be processed and transmitted. The encapsulation and tunneling processes inherent in overlay networks can lead to additional bandwidth overheads. This could potentially slow down network speeds and impact overall network performance. Despite these challenges, the future of overlay networks looks highly promising. The rise of new technologies such as software-defined networking, or SDN, and network function virtualization, or NFV, are set to further enhance the capabilities of overlay networks. SDN separates the network control and forwarding functions, enabling the network to be programmatically configured. This technology aligns well with the principles of overlay networks, providing even more control and flexibility. On the other hand, NFV aims to replace dedicated network devices with virtualized software running on commodity hardware. This could significantly simplify the deployment and management of overlay networks, making them a more attractive option for businesses of all sizes. In conclusion, while overlay networks do face challenges, the future looks bright. The ongoing evolution of technologies like SDN and NFV will continue to augment and enhance the capabilities of overlay networks, paving the way for more efficient, flexible, and secure networking. Despite the challenges, the future of overlay networks looks promising. In conclusion, we've journeyed through the world of overlay networks, exploring their key components, advantages, and practical applications. These virtual networks, built atop existing physical ones, offer a new level of flexibility in our ever-evolving digital landscape. They allow us to direct traffic through programmatically designed routes, breaking free from the constraints of physical links. Overlay networks also provide us with better access management, enhanced security, and improved redundancy and efficiency. They can be incrementally deployed without the need for ISP cooperation, and they allow for network edge virtualization, leaving the rest of the network untouched. Despite their complexities and potential for increased bandwidth overhead, the future looks bright for overlay networks. Technologies like software-defined networking and network function virtualization are set to further enhance their capabilities. Overlay networks are indeed a valuable tool for modern network infrastructure, providing a more programmable and adaptable solution compared to traditional networks.